Trojans Talk Research is a monthly spotlight on the research interests of Troy's faculty, presented by Troy University's Office of Sponsored Programs. This month features Dr. Chris Boyd and Dr. Xutong Niu, discussing developing and refining nature-based online decision support tools through technology and collaborative teams.
Welcome. Appreciate the opportunity to share our research. So my name's Dr. Chris Boyd. I'm the Associate Department Chair for the Department of Biological and Environmental Sciences and Associate Professor of Restoration Ecology. So I know a few people's faces in the room. So again, welcome, and then Dr. Niu.
Thank you for coming. My name is Xutong Niu. I'm a Chair and Associate Professor for Geospatial Informatics. And today I'm going to present our research basically since 2017 when we first team up to work on the project for living shorelines. So Chris, you can go first with the background introduction. Okay.
All right, thank you. Again, appreciate everyone coming today. So again, today we're going to be talking about developing and refining nature-based online decision support tools through technology and collaborative teams is the title of our presentation. And so you'll hear more about our partners and funders throughout the project, but as you see, we've done some of this, some modeling related to what I'm going to call nature-based solutions and living shorelines from Pensacola all the way over to Galveston Bay, and done some work in the Louisiana area in the middle. So I thought really I'd just kind of set the stage, talking about the importance of the Gulf of America. So give you a little bit about the importance of the Gulf states, and also information about some of the challenges, and really the remaining part of the slides are what can we do to maybe solve some of these challenges. So I think everyone likes to go to the coast. So really found this data a number of years ago, but they just show that pretty much everyone likes to go to the coast every year. So people live in Minnesota, they're going to go. Some come all the way down to the Gulf, or some will go to to the Pacific or wherever they might go. But pretty much everyone goes to the coast, and so hence tourism is really big. And coastal Alabama, Florida, Texas, pretty much all the Gulf, all the states. So people like to go and enjoy it. But problem is, if we don't protect and manage our development in the right way, we could really lose a lot of why we want to go to the coast. So again, we want to make sure to protect these marshes, because essentially, I couldn't seem to find this data, but it's somewhere. But they state that about 90% of all marine species, like shrimp, fish, ocean fish, they live up in the bay at some point. So basically, have more experience in shrimp, but they say shrimp, it's kind of born out in the big ocean where the full salt, near Dolphin Island or so, and they kind of float up into the bay. So they're going to hide into this marsh, so they can hide and grow and eat the food there. Same with little fish, and then they move back out and go out to the big water again. So what we realized that as people continue to move to the coast, that they might end up using some type of protection to protect their property. So it's showing here that on the Gulf Coast, northern Gulf of Mexico, about 1 to 6 foot of land loss per year. So really that doesn't really even take into account sea level rise. So again, that's just kind of historic data. So again, not everywhere is going to have that great amount of erosion, but do the math. If your property is 40 feet from the shoreline, you're going to have to do something. So most people have been putting in wooden walls, what we call bulkheads, or some rock on the shoreline. So again, most of us here at Troy might not really understand what bulkheads and seawalls are, but if you go to the lake, you have a dock. That's basically a bulkhead. But again, cumulative is what matters. So the point is, if 38, and at this point really about 40% of Mobile Bay is armored, we want to try to protect the remaining point, remaining amount we have left. So really, has anyone heard the term nature-based solutions? Or green infrastructure, I think probably a buzzword you hear sometimes on the news now. A lot of that kind of came from Denmark and from that area, building with nature. So building with nature is what really is about. But the point is, it's really complicated. I'm not going to get into too much about my past work history, but eventually I'm going to show you that before coming to Troy, I worked for Mississippi State University in Biloxi, so really on the coastal area. In Mississippi, Alabama Sea Grants when I started promoting these living shorelines. But really it's just, how can we get engineers and coastal engineers and property owners to, modify their shoreline protection in a little bit more what we call sustainable way. So over the last about 20 years, I'm going to show you that more and more people are using these types of structures. So really a living shorelines, I'm just going to go with the top one, a sustainable strategy to control erosion with features that incorporate native vegetation and natural elements designed to maintain natural coastal processes. But sometimes you're going to have to use both, like rock and, biological plants and stuff like that. So sometimes you're going to have to use structural and non-structural together. And we'll try to explain that to you. So really the first living shorelines that I'm aware of in Alabama and really mainly in the Gulf region was designed by Dr. Scott Douglas. He owns an environmental consulting firm in Mobile Bay, somewhere around Mobile, but he used to be an instructor in the engineering department, coastal engineering department at the University of South Alabama. His counterpart's Brett Webb. And anyway, apparently this is a golf course hole on Mobile Bay that's actually owned by South Alabama. And this is actually what they call a headland breakwater. Dr. Niu and I actually looked that up on Google Earth and it's still there. I'm not sure that the golf course is actually operational. I think that land might be sold, or I'm not sure, but it's not operational, but the structure's still there. My old boss, Dr. LaDon Swan, I built this living shoreline in Alonzo Landing, so really it's where the ferry is, Dolphin Island, when you go to Fort Morgan, protecting that marsh there. And that was in 2005. NOAA community grant was how that was funded. One of the first in Pensacola, one of the biggest ones really for a long time, was Project Green Shores, protecting Highway 90 in Pensacola. So again, that was just really a definition I put together for really a fact sheet a long time ago. I blended it from NOAA and Virginia Institute of Marine Science. Let's see, so really just trying to give you the, why living shorelines, and then I'll turn it over to Dr. Niu to talk more about these models, but really just trying to give you education on, why nature is really important. So these seawalls, they lose the intertidal zone. Again, sometimes you might have to have a seawall. You have really high waves and erosion, but there are ways that you can use more natural structures. So, and then the problem is when you're on a cove, one homeowner builds a seawall, then it reflects that way to the unprotected property, so then it's kind of like a domino effect. So in general, we like to say they maintain natural coastal processes. So when we design them, that's the intention. So you're trying to maintain the flow from one property owner to the next. Again, complicated, but these do, there's data out there that shows that, protecting these wetlands, reduces flooding. People in Tampa have told me that these living shorelines have really helped. After hurricanes and coastal storms, there's less water going on that highway, say in Pensacola, than there used to be. So, sometimes it might still flood, but the idea is that people can return back to the highway, a couple hours faster or a day faster, protects water quality. So basically, Dr. Douglas basically showed that as people move to the coast, more people are building some type of protection. Not rocket science. Rachel Gitman basically showed that nationwide this happens. So basically, the more populated a coastal area is, the more seawalls they tend to have. She worked for, I think, East Carolina. She's done a lot of research with living shorelines. Again, my past graduate student, Rose Horn, and Xutong and I wrote this paper. Really just what's neat is all this GIS, which Dr. Niu is really the expert, but I'm capable of pulling the data for simple statistics. But turns out these city planners and communities really need this data just to prove, hey, why? Again, basically, some of these areas, 37%, but sometimes you look at small areas, there'll be really high amounts of armoring. But there's reasons for that many times. But let's say in Mobile Bay, we are starting to gain what we call green infrastructure, living shoreline. So more and more being installed. So slowly but surely. So it's just a depiction that I inherited from Dr. Douglas a long time ago from a workshop that I used. So it is basically, you lose that intertidal, makes the water bottom a little bit deeper, making more sediment. So erosion comes from many different forces. I come from an agronomy background. My first workshop, I talked about the Dust Bowl, but really, when dealing with the coast, it's mainly wind-driven waves. But some of the things that Mississippi State University's been looking into is, they really think, well, our model is good, but could it be modified a little bit? Because our way mainly deals with wind, but it's really complicated. But in some coves where there's a lot of boat traffic, those boats can make these big waves like you see on the lake. So what is a living shoreline suitability model? And we're calling it a decision support tool. Again, I realized when I was still working at Mississippi State, my primary job there was to educate and to promote these living shorelines through policy and also to homeowners. But really it's just, and in the end of the day, Virginia Institute of Marine Science used to have a handout that they'd take to homeowners before GIS got real big and the internet and everything, or to the Wetland Review Board, and they basically have modified that and put it onto an online version. But it's basically like one of those books that, I don't know if you had when you were a kid, where you could go to different sections in a book. It's like, go to this story, that story, or keying out plants. So it's just, you answer a few things and then you come to a solution. And then, so basically I ran that first living shoreline suitability model in Mobile Bay about right when I came to Troy, and then started working with Dr. Niu. So fortunately, Ms. Judy Fulmer put me in contact with Dr. Niu when I was applying for that grant, and she said, well, you're contracting out a lot of GIS staff. Do you know we actually have GIS staff here on campus? I was actually full-time on the Troy Montgomery campus at that time, and that's when our relationship has grown. And so we did that with Virginia Institute of Marine Science, Geological Survey of Alabama, and Galveston Bay Foundation. It's a pretty big team, just basically proven. Virginia said, well, we'd like on this project this time, because it's getting bigger, which was a great help. We needed their advice, but then since that time we've been still using their model and giving them credit, but we run it in some different areas that we'll be talking about. So again, you can actually go to this website. So if anyone wants a copy of this presentation, just email Dr. Niu or I, and we can send you a copy of this by a link. Probably it's kind of big. But this is actually an open source platform data where, since I've been a member of this Gulf of America Alliance for probably about 14, 15 years now, mainly just you want these tools to get used, not sit on a shelf. The hard thing to do. But since 1998, there are now like 38 funded projects in the Gulf region from NOAA, obviously U.S. Fish and Wildlife Service and other organizations, and now private property owners. You see obviously more heavy, a lot more projects there in the east, started in Chesapeake Bay. So, but we're catching up slowly, and so it's taking root, and it's really kind of complicated. Due to the time, I'm not going to get into the policy of everything, but the idea is like, we need to eventually, be able to get a permit for a living shoreline about the same time you can get it for a bulkhead, so apples to apples. But again, used to it take 9 months, and still might sometimes, to get a permit approved, but it is more complicated to some degree. So, and you'll see that through. So I'm going to go ahead and turn it over to Dr. Niu.
Okay. So our project basically are trying to implement this particular model. You can see there's a flow chart with different scenarios based on the coastal conditions. Based on each of the flow chart, we have to develop a GIS model to provide final decision to the stakeholders. So what's the best way to protect coastal erosion? So my job is help Dr. Boyd to make it happen. I try to collecting data and process it and figure out what's the results of recommendation. So I have to use GIS data to collect all the information which are needed for this particular model. Okay, so each of these arrows represent different decision tree path based on different condition. You derive different solution for the coastal protection. And we also, based on that particular model, we develop multiple GIS online viewers. It's like a Google map, but the result of the model can be visualized and can be searched through these viewers. These are only a few of that. We did not list our recent couple projects because we're still under review by the funding agencies, or the project hasn't been finished yet. So, but these links, if you see the active link, you can click on them and see the viewer by yourself. And they are public, open to the public. And the factors we need to, in order to implement these models, we had to consider all these factors associated with the coastal shorelines. Things like land use types and marsh bathymetry, how deep nearby nearshore water is, if deeper or shallower, and exposure to fish means from this side water to the other side water, what's going to be the longest distance the wind can push the wave to, because the longer the distance is, the more waves going to accumulate the energy to cause more erosion. So that's something we had to calculate it. It's not as easy to just simply get shoreline, you get that number. You have to do all calculation for that. And bank height, existing structures, offshore structures, beach, all the information we had to look at latest satellite imagery or air photos, even drone imagery, to find out the actual location, property by property. Basically, we go through all the inches of shorelines at each location. We cover probably several thousand miles of shorelines to get these information, input them into a GIS system like database, and then process information. All right, this is another one, SAV, of forest shoreline or not, spit, tidal creeks, permanent structure or not. If there's a road, our house nearby on the shore, that's considered as permanent structure. We have to seek expert advices. And also canals and public boat ramps. These are also similar consideration to the permanent structure as well. And certain locations, we look at the marsh, but in Tampa, there are mangroves. This basically different region have different their natures, which have to base a local factor has to be considered. We need to modify our model correspondingly. So basically, not one model fits all. We have to talk to the local residents, local funding agencies, local people to understand what's the local problem, modify the model to fit to the scenarios. And one of the challenges I'm facing is basically deriving shorelines. How can I get shoreline? Because shorelines are baseline. We put all the information on the shoreline, color-coded, really just put attributes along each segment of shorelines. One of the challenges is get the shoreline digitized. This is data we have. One the site in the Pontiac Indian tribal area. You can see there are a lot of marshland, and the shape of shoreline is really complex. If we manually digitize this shoreline, it would take our months or years to get it done. So we had to find a better way to automatically extract that. That's become my first challenge. So one of the things I did is, this is color image, satellite air photos. This is one of the colored, we call it near infrared band. If you learn this remote sensing, where the water absorbs near infrared light. Okay, so if you take that image, any parts of water is become black. So it gives us a very good data. We can distinguish land and water. Okay, so I use that kind of as a clue to basically separate the data, make it do binary data, okay, which give a threshold, so I can easily extract the data for this kind of area, so you can get shoreline automatically using a GIS data processing. So that saves us tons of time, because that's one of the challenges we conquered. Another is like getting data up to date, because not everywhere along the coast you have the latest imagery. Okay, we have to find a certain, so we have there, the data we have was like 3 or 4 years ago. Does not reflect the latest condition. So we had to find fly a drone to collect data. So this is one of the places I flew last year. Went there a couple times, collected over 10,000 images, and process them in a big computer workstation. It takes a couple days to process them. We can derive the images, derive infrared mosaic together, and extract shorelines. Also, of course, I had to conduct GPS processing to make sure everything georeferenced really well and can be used in line with other data we collect from other sources. Okay, that's another challenge. We finished that. So basically, one of the other challenges I'm not involved too much. Really, Dr. Boyd, he has done a lot. Is talking to the stakeholders, talking to the people local for outreaches. We had to basically tell people why it is important to build a living shoreline to protect your properties. They want to protect properties, but what's the best way to protect is adopting this living shoreline strategy. Okay, outreach is another very important thing. And we also developed, part of the project is developed as a permitting guide, or working with the local government agencies to facilitate permitting approval process.
I'll just elaborate just
Yeah.
for a second on that. Just what we come up against, since we're from Troy and going to Texas and parts of Louisiana, you create a model. If the locals or the permitting agencies aren't behind it, if you don't have the buy-in, it's just not going to get used. And it's good to do projects, but you have to work through that. And every state has their own regulatory challenges. So all states are pretty much always are trying to promote nature-based, but there's different policies. So if you want to, Louisiana is very complicated, and they finally do have this. I did find it from Nikki Pace. I used to work with her. She's an environmental lawyer at LSU now. I used to be at Ole Miss, Sea Grant lawyer. But anyway, they now have this. But main thing is getting that local input. And Dr. Niu is going to talk a little bit more about the Pontiac tribe and that. But these two case studies were ones that we've had real success where our stakeholders or the groups we're working with really, they really challenged us in a positive way, sometimes a challenging way, but a positive way to make sure we get it right.
Yeah, so we're going to present to you 2 case studies among all these projects we have worked before. So one of that is at Pensacola Bay or Perdido Bay. So right now this is our latest project. It's still ongoing. It basically covers both sides of Florida and Alabama for Perdido Bay. If you've been to Origin Beach, that's where the water is, okay? So basically we help the Nature Conservancy, they are our PI, the funding, they got funding from NOAA, where part of big team is over like $13 million big project, we're only small share of that. But this will help them to update the linear shoreline model. We have developed a similar model, same model before, through the PPEP, that's Perdido Bay, Pensacola Bay Estuarine Program, about 3 or 4 years ago. Then the new funding asked us to update those and also make some changes to the scenario where they can think for stakeholder do a cost share programs, all right? So we redone that basically for entire bay, based on latest the drone imagery. So we did not fly the drone, but Mississippi State, there's a team, they work with us, they flew the drone basically along all the coastal line of the Perdido Bay. I'm not sure you can see the separation of the grayscale between images. That is drone image, that's the background from Google images. So that's the one we use that to digitize shorelines, and then we color-coded shoreline based on different conditions, different attributes. And this is structures. This structure shows you that you can see different color coded. Bulkhead for the pink color, the green means no hard structures, and the orange means riprap, and blue means unconventional. Pretty much you can see pink and orange are basically dominating this particular area, either riprap or bulkhead. So the green are the natural shorelines, we can call it, either beach or marsh. This is another one for offshore structures. You can build breakwater. It's not on the shore, away from the shore, but prevent the waves erosion. So the breakwater groundings, marsh toads, they're very little over there. And this is the seagrass data. We get data from the local government. They do coast seagrass mapping. We use their data to help us derive information. Basically, we create a buffer. If they're nearby, within 100 meters, there's 30 feet or 30 meters, there's some seagrass, which we try to put that seagrass over to the shoreline, coated the shoreline with nearby seagrass. This marsh present, you can see that yellow means there's no marsh. Green means there's marsh present. Pretty much majority are no marsh anymore, okay? And then another one is called fetch. A fetch is the one that you say, for example, this point. So any point on the shoreline, when you find a longer distance from this to the other part of land across the bay, across water, okay? So this is really complicated. Shoreline we collected are in, we call vector data, basically small line segment. Each segment can be modeled using a linear equation. So you want to figure out whether this line, okay, we go this line, so basically we can start from the point, you can draw lines all directions. We figure out which direction has the longest fetch exposure. Basically we have not only, it's not that easy. If you learn mathematics, you can find out does this line intersect with any of these line segments? We have millions of segments along that coastal, that single bay. Then every line you have to try to check whether it's intersect with the others. And then for every point, we have 16 or more directions. So that if you do that calculation, you will take several hundred days to finish that calculation. There was one time I run the model on my computer. I waited for a day, a night, still running. I thought my program dead. I shut down the computer, and I realized, no, that's not. I had to wait for longer time. So we cannot afford that. Okay, the time cost is really too much. We could not finish the project. It would take this many days. So I have to redesign the algorithms to convert data from the vector like lines into pixel like images. All you need to do is simply counting images. Go from one point along that direction, okay, step by step, until you hit a pixel which is a land, you stop. Basically, you're walking across an image. It's basically simulate that kind of process. In this way, I don't have to figure out whether this line going to intersect here or intersect there. Only one direction. So that saves a lot of time. I can finish that whole bay within less than 2 hours, 2.5 hours. So that's basically a big achievement. We use that method basically for both Pontchartrain tribal area and this Pensacola Perdido Bay. So that's a very small program, very short, only a few lines, but that big achievement right there. So that's a fetch layer. You can see this is a comparison. This is the old ways we did. This is the new way we did. Old ways we could not have very high resolution because time cost. We basically can only have like 16 directions. The new one have 5 degrees, so 72 directions. I can get much higher accurate results. This area, some are green now become orange or red because the old model could not be, this area cannot be identified because of that gap between the larger angles. Okay, I can minimize the angle. I can do any direct distances, intervals I want, still within a short amount of time. Okay, but the good thing with this also, you can see that there basically is very good table would also look at the other data. The fetch is very important. Why? Because the higher the fetches are, the more gray structures people are realized. They build a lot of hard structures to protect that. But we try to see any other better ways to do it. Okay. We also use topography for water depths and land height. So bank height, water depths is from the high resolution LiDAR DEM bathymetries. So this is the model we developed, and that's basically is online, but we cannot share the link with you because we have to get approval from funding agencies. Just to give you a picture, screenshots of the system we developed. All right, the second place is in the Pontchartrain Indian tribal area. This is a satellite imagery. That's how big that is. Right below the New Orleans. New Orleans is right up top of that. Probably 7-hour driving from Troy. Okay, we go there multiple times in the past few years. You can see majority of the land are marsh islands. Only a very small piece right there, that's where people live. Okay, but the reason we try to do the project is to help them to protect the coastal marsh. The land loss over here are really huge. Some places you can lose 30 meters or 100 meters a year. I have historical data I did not show you. I didn't have it here, but I don't want to create that kind of wrong message, some message to you. But really, it's really important to protect them because more and more they're losing more and more land. So we want to make sure protect their. Oh, this is the data we collected based on the attributes. These are all different factors we developed, and this is the results we collect based on percentage. We have different recommendations for this area. These are all the agencies who are involved in this project. The funding agencies, I think PI is from Louisiana State, and LSU, and Louisiana Sea Grant. Troy is one of the participants, and the Mississippi State, Southern Mississippi, and all the others involved as well. Yeah, go ahead.
Just a second. I thought this would be interesting since
you go
I
ahead.
appreciate everyone coming today. But you know, I guess the one thing is that in the Perdido area and really every other area Dr. Niu and I have been working in, you know, it's more like development, and development is causing the problem. But when I was working at Mississippi State, I go to meetings in Louisiana, and you know, in grade school you heard about, oh, well, they're losing football fields of marsh, but you know, this is the first time we really, it took about a year before to really let it sink in, because you know, all these are actually offshore breakwaters built by Ducks Unlimited. You'd have to get us pictures again. If I can share more information if you're interested, but I realized, wow, they're really protecting this land. But the problem is there's oil and gas canals, and you know, the fact is that Mississippi River has, you know, dams all the way up to Minnesota, and that sediment is getting caught behind the dams, and they're doing different diversion projects in Louisiana and maybe north of there, I'm not sure. But the problem is there's less sediment coming down the Mississippi River, and then as we extract the oil, there's some what we call land subsidence. So if you take groundwater out, the land can sink a little bit, like in California. But if you take oil out, it sinks a little bit. So they're not only losing sediment, the land's sinking. So that's kind of what that's about. And then so they've really lost. If you look on the big scale, lots. It's the largest. This is the most eroding place in the world, apparently. So we feel honored to be on the project, but it was originally a little bit intimidating. But the main thing is, working with a Pointe-au-Chien tribe, and went to a lot of meetings, and they have what they call the traditional ecological experts, are really, and another team where they're just giving us advice, and the craziest thing is I learned that they're coming right outside this canal. Most places, in Mobile Bay is like 10 feet deep, or Perdido Bay. For some reason, it gets like 30 feet deep. So you couldn't put structures out there. So we had to change our recommendations to make sure, you don't want to recommend something that's going to be cost prohibitive. So anyway, we learned a lot, and we tailored it, and blessed that Xutong was able to help make those changes based on the advice that we were able to get. And we had a huge team, even with sociologists and things that would really get more out of it. So that trial's been there since 1300. So anyway, go ahead.
Yeah, one of the things we learned from this project is working with different teams, and also we want to share some of the results our big team developed for this project area. So this is a Professor Dr. Yao Wang from LSU. She is a landscape architect, and her team finished this design or final product. We're going to be on phase 3 or in the next starting April this year. So based on our model result, we got starting to design. This is part of the final product of previous results. We're going to make this is basically you can see the drawings showing you different kind of protection methods, and this is basically a profile of the local area. This is a canal, and that's the bay. You can see there's some marsh and a lot of dead trees over there. Pretty much is covered by the marshes. You can see different ways of oyster beds or Cajun corals or rocks and different mats. But that's basically the strategy we try to adopt to apply over the coastal area. And this is another one on the both sides. There's small canals in the community area, so they try to build some ripraps to help protect the community where they live. And this is another way to design this different ripraps over at the coastal area. So just try to share with you, not only just get GIS there, you have to make it happen. In order to make it happen, have a better design. This is something we think very beautiful, also directly showing users they can use this immediately based on these drawings, okay? All right, so lesson, you want to talk about lessons? Or
I guess.
Yeah, go ahead.
For sure. But anyway, as you say, it's real complex, and we could kind of talk a lot more, but I just want to go back, just since I appreciate so many students coming today, but when I still worked at Mississippi State, there was a gentleman, Tyler Ortega. He would come to these dredge meetings, meaning they would dredge the canals or they're dredging ship channels. And Tyler, he had graduated from LSU, but he would come to Mississippi because he started his own business, and then he learned about living shorelines. He makes these with 3D printers now, and he's been at this for like 20 years, but he just said, well, it took me 20 years, but he's finally making real money at it. But he does that with concrete and makes those 3D structure. Anyway, really neat. But just trying to show that application. So his idea is that he builds these so that oysters recruit. So he builds it. He's like, well, I can build them any weight, but the problem is you got to put these on barges and and dredge and anyway, it's complicated. But I'm always amazed at what engineers can do. But anyway, Dr. Niu will help me with these lessons learned. So I really just put this down at one point at a couple of the conferences I've been to. But the main thing, I think we've already addressed this, but when you're building this living shoreline model, again, it started in Virginia. There's a lot of people on the coast and say, well, we're not from Virginia. But still erosion's everywhere. But basically you take a model, but it's specific. So ecosystem, so each geographic water body is different. So again, mangroves, I'm not sure how many people know about mangroves, but they mainly, they're starting to come up towards Alabama and Louisiana, but they're mainly, I think that it's been a while since I studied them, but they found some in that Pointe-Noire region, but not so many. They mainly stop, I think, Tallahassee, but they could be starting to come up with sea level rise, so they'd like a more salty environment. So the question is, Mars first, mangrove, but in general, we learned that we kind of, if you can build one, you can build the other. So, looking at the ecosystem concerns, down here we started working with seagrass. Definitions matter. That's the most challenging thing. Most recently, we've had a lot of work with some of our teams where they've actually been looking at our definitions, but I'll always give this assignment. It's kind of like a homework assignment to people, and then, I don't know. Sometimes they just say, we'll just go with whatever you have or Noah already had. But it is important. So again, putting that local language is important. And again, most importantly, they need to be permittable beyond the scope of this presentation. But again, don't want to recommend something that and you're not going to get it approved. And this is probably way more information. But what Dr. Niu we didn't really tell you. See, he was able to create that land law, land versus water. Because we realized we would never finish that project. We realized about 4 weeks into the project. But I hand digitized a lot of things, and then I turned over to Dr. Niu. He did all the really hard calculations and everything. But I'm surprised my eyes still work. But basically, you create that one line, and then you connect all the attributes to that one line, and then he runs it. So the problem is, you need to be as accurate as you can, but the problem is once we publish it, then we have to update it. So the problem is, how could you do the whole United States, or how could you, most importantly, when the Nature Conservancy goes out and educates everyone, that's why they wanted to pull out the drone, because they were like, well, your model's in the water now. And it's like, so they're like, then it makes you not look as good, but the problem is the land changes all the time. So, that's something Dr. Niu and some of his undergrads and us and others can look at. How do we update that, over time? Good. So anyway, a special thanks to a number of our students.
Yeah, we basically educate train several students throughout the years, several graduate students. Some are still here with the program in the Department of Biology and Material Sciences, and some are geomatics students or GIS students from Department of Geospatial Informatics. So basically, we highly appreciate their hard work, and help make this happen, and get this project done. So,
yeah. And I was able to. Fortunately, I met a boat captain, and he lives down at Orange Beach, at least on that project, and served on that Destin project too, Choctawhatchee Bay, and really I call him Chief Donald, but Captain Donald in Louisiana. But really, with the boat captains are really critical. They can tell you, they'll be first to tell you what will work and what will not work, and then most importantly, Dr. Niu got to learn how to dodge thunderstorms and things like that.
Yeah, especially when we fly the drone, we had to watch the weather all the time. We had to get up early to fly the drone just to avoid the thunderstorms coming. So that was kind of challenging. Also, under the sun, you had to conduct GPS collection control points. I have walked about a couple miles under the sun in the hot summer, August last year. So it was a very nice experience.
Yeah. So I believe that's all we have. So
thank you.
Trojans Talk Research is a monthly spotlight on the research interests of choice faculty presented by Troy University's Office of Sponsored Programs.